So today we are going to look into steps to building machine learning models. Especially, I know last week we talked about cost of dimensionality, where we explained these concepts, how it can affect the model being developed. Following a couple of feedbacks and kind of questions, I do a counter. We had to talk on this topic. People know how to do machine learning, and also based on my personal encounter with some of my students. So what are the steps? Sometimes we do confuse this step with the experimental setup of earlier work. You see? So what are the steps that need to be taken when you are building the machine learning model? So you will see in several maybe publications, they just present a flow chart, as we're going to see. So is the flow chart just going down like that? Once you leave a step, you don't come back to it. You keep going down until everything is perfect. Is that the way it works? So that if I want to do, for example, data gathering, once I finish data gathering, I don't need to go back there anymore. I have to go down to the next stage, and I keep going down, down, down until I finish my work and I conclude. Does that really work in that way? So definitely far from the reality. So that is why we say today we're going to talk about what are the steps that we need to pay attention to when we build machine learning models. We say important clarification. We'll be clarifying some points, some mistake we notice that people are making. So when they are carrying out these machine learning modeling procedures, some ignore some go to the extreme of spending so much time on some steps rather than going forward and then letting the iterative process take its place. So we are going to give some of this classification that hopefully that is going to be beneficial for all as we trying to benefit ourselves with the modeling of our different systems using machine learning algorithms. And also we say, always let the data speak, which is very, very important. We always want to see the data set tell us how it is. What is the quality of the data set? Sometimes you need to let the data speak. See? So letting the data speak means that the data will be able to tell us where to look into. See, if the data is really having issue, we'll be able to know that, oh, there are issues with this data. And there's no issue with the data. We can concentrate our energy on other things, as the case may be. So this is going to be the import of today's presentation. As we have been showing, this is what I often call the standard iterative process of machine learning steps. Making it iterative is very, very important. You see, because we've seen several ones out there. You see here, some people say it is 6 steps. You see, modeling, machine learning, building blocks in just 6 steps. Some people say it's 6 steps. Conceptualize your machine learning, your organization, explore the data, and choose the type of algorithm. And choose the type of algorithm. This, you see, how do you choose the type of algorithm you want to know? How do you know the algorithm that is going to work for you? You see, some steps become very unclear. Prepare and clean the data. So split this prepare data set, perform machine learning optimization, deploy the model. This is one opinion. Another opinion says that, okay, there are 10 steps in machine learning building blocks. Define the objectives, gather the data, clean the data, do what we call EDA, the explanatory data analysis, which is like doing statistical analysis of the data, feature engineering, feature selection, so model building, model evaluation, then optimization and conclusion. Is it just a single flow line like this, or how should it be? Some people just put it in their flow chart. Okay, you start here, you have you gather the data, and then data gathering and then preparation combined, data preprocessing, and then you go to model building, then check the model if it's okay. Is there any need for refinement? Then If there's need for refinement, yes, do parameter tuning, which is hyperparameter optimization. Go back again and then build the model and then come back. If there's no need for model refining, then you come here, you build the final model using the hyperparameter obtained, validate the model, use it for prediction, result analysis and interpretation, and then identification of hotspots. Yeah. So here, there's iteration here, but does it mean at this point in time, we cannot go back to preprocessing again once we enter this block? Because this is the feeling that this kind of flowchart has made us to realize here. So once we enter the building block, it seems we are stuck. But no, that's not the case. You should always have the freedom to go back. You might actually need to go back to gather another data set. See? So that is why I said there, I need to make some of this clarification based on some of the questions I do receive. People get confused. They got stuck in some steps, thinking that they cannot go back. No, you can always go back to previous steps and trying to redo whatever you have done. Now, so another model building steps, is it a model building step or someone's experimental description? You see, people tend to confuse them together. Someone just build a model, then it try to let us realize, okay, what are the experimental procedure that it passed through? So this is an experimental procedure for some people. This could be also for another person, actually, procedure he passed through. So it doesn't really make it to be a generalized procedure that we all need to pass through. Sometimes we don't need some. Sometimes we need some of them. So this is why I said how today there are a lot of flowchart, lot of proposed, suggested procedure for machine learning building. However, we need to be very careful that we are not misled into thinking that any of them is actually maybe compulsory, that you have to do it, either you like it or not. Of course, there are some that you cannot run away from, like modeling, using the algorithm to do the prediction or the analysis of the data for sure. So since we are out there, personally, I do recommend the following, and especially the one we have been using, which we are going to use today to again summarize it for us. I said, always let the data speak. This is very important. Always let the data speak. So what you need to do is to start with the raw data set before applying too much preprocessing. Some data set comes to you. It can work on your model. Try to run it. Let us see. Let the data speak. Yes, you need to do a lot of things. Outlier is there. But let the data first speak. See how it works sometimes. See? Always use the iterative process idea. This is where I'm going. Always use the iterative process idea. Don't get stuck with preprocessing. But I've seen where people want to spend so much time on preprocessing. You see, even in the course of doing the preprocessing, you're already mutilating the data. We don't need to do that. You see, when you do, there are some preprocessing that are compulsory that you just need to do. Then you have to do them. For example, you have in your data set ID, you have to study the data set. That is under feature engineering. Look at your features that have been provided, maybe sent to you by client. They don't understand what is feature, so you need to define what are the feature, what are the outcome. Okay, this is going to be the outcome we want to predict. These are the features we want to use. So once, okay, we found out that there's ID there, student ID, like matriculation number or student ID or student name. You don't use name as feature for prediction. You don't use ID. You need to remove some of those ones. These are very, very compulsory preprocessing you need to do. See? And few other preprocessing that will not make your modeling have any sense or make any sense. You need to do it compulsorily. However, not all preprocessing need to be done before you move ahead and then see how the data is actually. For example, I've seen students started immediately, oh, the data is imbalanced. I need to start to balance the data. Let the data speak first. You see, let's see how the data behaves with the imbalanced data itself. So run the model. See, that's why I said always use the iterative process idea. Remember, machine learning is not a dogma. So you need to try different algorithms and options. You see, you can read a lot of things. Okay, whenever you are dealing with a medical data set, you use support vector machine. It doesn't always need to be. You see, there could be some data set that will not work for support vector machine, even though it's from the same area. So whatever anyone maybe wrote down before is just an advice. He thought that, okay, based on my experience, support vector machine always work on medical data. It doesn't mean it's going to work on all data set from the medical. And that is why this principle of let the data speak is very, very important. So don't pay too much attention. I've seen people that will recommend that, okay, if you're using support vector machine, you must search for hyperparameter C to be between 100 and 120. See, I've seen students that stuck to this. I say, okay, what is parameter you use? He said, I use between 100 and 120. I said, why? Did you search for the best? He said, no, I read it in one paper that this is the most likely best. I said, no. You see, the principle of let the data speak does not support such idea. So we have to be very clear with that. We need to check. We need to search for ourselves. Maybe this data set is totally different from the one you used before. So these very simple clarifications are very, very important, as day in, day out, we come across people making these mistakes. And of course, they wasted a lot of time on the modeling, and at the end of the day, they couldn't get what they were supposed to get. And then take next step based on what you can deduce from the data modeling outcome. You see, once you allow your data to speak, then it will tell you that, okay, oh, this thing is not working. What can I do? For instance, I've seen a case whereby the data is so imbalanced, but very imbalanced data, highly imbalanced data sets, which of course we knew we were going to do data imbalance. But let the data speak first. Run the experiment using the imbalanced data set. And surprisingly, we see that people got almost 100% in the testing set. You see, even though it's imbalanced, we see data set like that perform excellent way. All the samples, including the minority sample and the majority sample, they were all correctly classified during the testing set. You see, it means the issue of being biased towards the majority does not even arise because you are able to achieve 100%. So even if you're going to do balancing later, it's just to see, okay, if we do the balancing for future's sake, what can we do? But not to prevent the original data from communicating with us. So let us see the outcome of using the original data set. So this is very, very important. I want us to take note of. So, and that's why we say always let the data speak. Now, since we have seen several types out there, several procedures that people do recommend. So I personally recommend these basic machine learning building steps. So where you have here the data, and you have the algorithm, and then we have the model. See, of course, you cannot do anything without data. Under data preparation, also you can say data gathering is there, included there. You cannot prepare what you don't gather. That's okay. So you can't prepare what you don't gather. Sometimes you gather it yourself. Sometimes it has been gathered and given to you. Then you need to get the data ready in the form that you can use on your model. See? So that's why data preparation could involve what people often refer to as preprocessing, also are there. Preprocessing. So like we wanted to be sure that, okay, this data set is not containing invalid features. For example, like I said earlier, name of samples should not be there. In fact, when we do machine learning modeling, we do request for what we call anonymized data set. That is anonymous data set without the name of the patient, because this could be a very big issue. And this is a clarification we do make for the IRB, those people that are in charge of ethics in medical, that when we are building machine learning model, we don't need patient ID. We don't need anything that can make us trace the patient. Even if they can remove the medical record of the patient, that is okay for us, because we are not dealing with them. We just need the data set. So that's why we call it anonymized data. So once you get your data set, you make sure that the names are not there, the IDs are not used. then you can take in your data immediately. Okay. Under preprocessing, we might deal with, like as another topic already, we had it earlier. You can check out our videos on preprocessing. We have one of the very common preprocessing is missing value treatment. You see, some algorithm or some environment, some platform will allow you to even though missing value is one of the very important steps that you often need to do during the preprocessing stage. But however, there's some platform, depending on the platform you are using. Like I was saying, that missing value is one of the very important preprocessing steps, but still, there are a couple of platforms that will allow you to run the experiment even when the missing value are there. See? So in that case, you can just say, okay, let's see what's going to happen, even with the data we have, because some of these platforms, they have inbuilt missing value treatment. So there's not going to be any error or whatever that data is missing data. Of course, some programming environment will not allow you to do this. So we can say that, okay, apart from missing value that you need to treat, we discussed earlier, there are several methods of treating missing value. Either you delete them or you try to do estimation for them, or as the case may be, you can refer to our earlier videos on this. However, then we have the outlier. Outlier is just like a number, just like a value under any feature, but it's not correlating with, it's not falling within the range. So you can go ahead and do your modeling even without doing that. And later coming back to try to see, okay, if something is wrong, my result is not as I expected, I can treat it. If you like, you can treat it, that's fine. You can also treat it before you move on. But it's not one of, because outlier is very challenging to detect, as we described earlier. You see, outlier, what is outlier in one features, in one column, might not be outlier in the another column. You see, for example, you have age of students. You see, in that case, if you see 120 under age, it's an outlier. It's very rare to, if you see a student to be 120 years old in an undergraduate program, or as the case may be, or you get to have 1,000 years. That means something is wrong with that kind of data. You see? So this is what we call outlier. But in another column where you have the stipend for students, stipend. 1,000 under stipend is a normal value for student monthly stipend, actually. So what is an outlier in one column is not an outlier in another column. That's why outlier is very challenging and difficult to deal with. But sometimes you can still run your model, like I said, even without treating the outlier. Then later you come back. Depending on the kind of model you are building, you might be able to even do without that. Now, so there are other pre-processing also that could be done, like, okay, imbalance treatment, which personally I want you to, once you do the most important pre-processing stages, like missing value treatment, it's very good to treat your missing value. Or you don't have any missing value, you don't suspect any outlier. If you suspect outlier, how serious is that outlier? Let the data speak. You see, the only thing I think can affect your model critically is missing value. Because in some areas, it will not, some areas or some platform, the algorithm will not even work if there are missing value. While in some other platform, even with missing value, they can still allow you to go ahead. So this is why I said earlier, missing value treatment is very important, actually. However, for outlier, because outlier is a relative term, how far is that outlier going to affect your model? For me, I prefer you run your model, build the model, even using with the presence of the outlier. See, since you always have this opportunity of coming back. See, there's an iteration here. So once I do some basic preprocessing, I don't waste too much time there. Move on to the next stage. That is selecting your algorithm. See, use, as usual, we say, start from simple algorithm. This is very important. We've discussed this earlier. From simple to the complex. So use very simple algorithm. For me, I start with KNN, run it, see what you can get. Check the model. The model is built now. Then check the performance of the model. Despite, I didn't treat my outlier, you see, yet I was able to get 99% accuracy in the testing set or a validation set. It means something is good here. See? Okay, but sometimes nothing works. The maximum you could get is just 50%. Oh, then maybe you now say, okay, should I go back here? This is opportunity for iteration. Should I go back to change the algorithm? Or I just need to do hyperparameter optimization. Or I even change the model, because hyperparameter is very important. If you don't do the hyperparameter, it might be difficult for you to determine, to decide that, oh, this algorithm is not working for me. I've seen people make this mistake. So they use the default value. Yeah, sometimes default value could work on data set, but very rare. For example, k nearest neighbor 1, k is equal to 1, is usually the default value. But it doesn't mean k is equal to 1 is going to work always. There are some data set that you need to set the value of k to as high as 11, 17, or even more before it gets the better result for you. So hyperparameter is very important. So you go back here and do your hyperparameter optimization. If you are able, it works for you, then maybe there's some other selected algorithm. One question, okay, what are the algorithms we can use? Like I said, start from simple. If you are going to have clients that might ask you, how is this thing working? KNN is one of the algorithms that you can easily explain to your client. Decision tree also is very easy to explain to your client. See, then based on literature, if it is maybe this is something that has been done before, it's always good to go to the literature and try to reproduce the result of those people that work in this area before. See, actually, did they really get what they claim to have gotten? Then can you improve upon what they have gotten? This is another way to know which algorithm to use. Otherwise, start from the simple. Maybe you are the first one to work on this data set. It is a totally new data set. No one ever worked on it. Then you start from the simple algorithm and then gradually goes to the more complicated ones, like supervector machine. You might have to try out maybe deep learning if they are involving images or videos. And you might have to go to ensemble and hybrid if things really get really complicated, that your model is not getting to understand the data properly, because some data set could be really complicated. Now, so you go back, going back, iteration might have to go back just previous step, which is under the algorithm, change the algorithm, do optimization of hyperparameter for the algorithm, and then you build the model again and check the performance. And sometimes, like I said earlier, you may have the opportunity to go back either to the feature engineering step, where about, okay, what are the features? Maybe these features are not working. Can I use a feature to produce another feature? Do I need to do some manipulation on the feature to generate another feature from one feature? And so many other feature engineering steps we can take. So sometimes we might need to do feature selection, because actually feature engineering also include feature selection. Sometimes you see people separate it together, separate feature selection from feature engineering, but classically they are also together. So I want to go back, okay, let me do feature selection. Okay, what are the features that are better suited for this? And there are several feature selection methods that we've discussed. We can refer to our earlier videos on feature selection types. And sometimes it's not just enough with the feature selection, then you go back again, do your modeling and check the performance. But sometimes you might have to go back totally to the data. Now you now see that, oh, it seems the outlier in the data set is really a big issue. Okay, I need to go back and treat the outlier. And sometimes you might find out that, oh, I need to do normalization. I need to normalize my data. What is normalization? You use normalization when you have different values, different value ranges. Ranges of value are so huge among the features. This feature, the smallest, the range of values like 1 to 25. While you have another one that is just 0.2 to 0.3, maybe medical test. And you have another one with maybe 20 million to 30 million. You can see this is a big range. When you have different range of value for each of the feature, it might be difficult for your algorithm to really be able to understand the data or to model it properly. In that case, we can do normalization, in which case we want to convert all the values to the same range. Okay, I want all these values to be between 0 and 1. 10 million, 20 million, everything will be converted to between 0 and 1. This one also 0 and 1. So that we'll be dealing with the same range of value for all the features. This is normalization, but it's totally optional. You see, it's totally optional. In fact, let me make a point here. Recently, sometimes we overdo the preprocessing. This is one of the areas I've seen students spending so much time. And I say, no, it's not necessary. The moment they get the data set, they normalize the data set. Why are you doing normalization? That was my question. What is the need for your normalization? I just think we need to do preprocessing. Yeah, you need to do preprocessing, but not all preprocessing are necessary. You see, normalizing the data without even seeing that there is effect of lack of normalization on your data set might actually make you miss your opportunity. That is, let the data speak. The more original your data is, the better for you, by the way. So a couple of weeks ago, one of us, the student team received feedback from reviewer regarding on their research outcome. One of the comments of the reviewer was the concern that since you normalize your data, and then was raising some concern about it. And that's okay. Do you have result of experiment you did without the normalization? Because you can easily use it to convince him that when we didn't do the normalization, the result was very poor. So when we did the normalization, then the result became improved. This is a justification that the normalization you have done is really necessary. But otherwise, you don't just do it as part of preprocessing steps. But we have so much preprocessing steps. See, missing value treatment, outlier treatment, normalization, imbalance treatment, feature selection, so many things. Do we need to do all this before we proceed? I said no. And actually, this is one of the clarifications that I said we need to make for ourselves so that we can know that in machine learning, be very flexible with what you are doing. No matter the recommendation from previous researchers, it's just recommendation. It's not binding. Always remember the principle of let the data speak. Sometimes, the moment you normalize your data, the performance goes down seriously. I've witnessed that. So it means it's not in all situations that normalization will work for you. So preserve the original data set. Unless when you have done whatever is possible to be done, but nothing is proven, then you now go back and do this kind of, we look at the statistical analysis, we notice that the range of values are a little bit more. Can we try to normalize the data and then normalize it and go back to this development system and try the system all over again? And sometimes you'll be so surprised that the same normalization that work on one data set, it doesn't work on another data set. And that's why we have different types of normalization algorithms or formula. So which one to use? So things like this, you don't have to make it as a compulsory stuff that must be done. So this is a very important clarification that we want to make for ourselves. The moment we get our data, always remember that you have the opportunity to go back. That should give you the feeling of the flexibility you're having in front of you. It's not something that once you enter a step, you cannot go backward. No, you can always go back to redo what mistake you might have made. So once you start your data, move ahead from data, go to your algorithm, picking the right algorithm, do the modeling. You can always go back like we discussed. But actually have to go either do hyperparameter optimization or replacing the algorithm or combining the algorithm to form ensemble or hybrid, as the case may be. You can play with these, several options there. Or you might have to go back to the data cycle totally, whereby you want to do, is it feature selection you want to do under feature engineering? Do you want to change the features? Do you know, manipulate the feature, add one or two features to generate a unique feature, as the case may be? Or you just need to do some preprocessing steps on the data set. And sometimes you might need to go back to the data gathering stage. You see, data gathering stage. You remember when we discussed missing value treatment and outlier treatment methods, one of the best method for treating missing value is for you to go back to where the data were collected from or was brought in. You have to go back to the source of the data. This is the best method for fixing the problem of outlier or problem of missing values. You go back to the source and regather the data correctly or ask them to correct the data. But we said, even though it's the best method of fixing missing value and outlier, it is always impossible because sometimes the data set have been collected a long time ago and the people cannot even identify where the error came from. It could be from the machine or whatever. So that's why I say that in general, be aware of the fact that there is flexibility when you work on model building. You have that flexibility of going back or going forward, keep the iterative process active until you are able to achieve your desired goal, as the case may be. And finally, we summarize again. Always let the data speak. Start with the raw data set before applying too much preprocessing. You can see too much. Don't stick too much to it. Most important preprocessing should be done. You move on. If there's need for other later, you can do it. You see? So like normalization, it's not a must, you must do normalization. You do normalization as a last resort. If your model is not really performing, you try to say, okay, maybe normalizing the data might help me. Sometimes it helps. Sometimes it might not help. And sometimes doing it right from the beginning will make you to lose some information or insight you might have to your data set. So always use the iterative process, very important. Remember, machine learning is not a dogma, so try different algorithms and try different options, and always work on the principle of let the data speak, and take the next step based on what you deduce from the data modeling outcome, as the case may be. So we're going to give room for question and answer. This is where we're going to have it for the day. Thank you very much for listening, and I wish all the best.